Hello, friends. Welcome to our channel. I hope you are all in a very good health and studying well with your full focus. Today, we are going to discuss about spherical mirrors. So, as the name suggests, if we consider a mirror which is sphere, okay, this is a sphere, this is not a circle, okay, this is a sphere, this is a 3D object. Now, if this is a sphere and if we consider this is the reflecting surface, actually the mirror is not a complete sphere. We are imagining it in the form of a sphere. So this is our mirror. Let us call it AB. So AXB, this is our mirror. And if we complete the mirror, it gives us a sphere. Similarly, we can consider another case where this is a sphere and this is our reflecting surface. The reflecting surface is inside in this case. So this is also a type of spherical mirror. So light ray can come and get reflected by it. Okay, this is the silvered surface. Okay, so the shaded portion is actually the silvered surface. Okay, and this is our reflecting surface. So we can say this is our silvered surface. And the opposite of this surface is the reflecting surface. So this is our reflecting surface. So light ray comes, and after striking the mirror, after striking the reflecting surface, the light ray gets reflected. Okay, so this kind of mirror is called concave mirror. And if the silvered surface is inside the mirror, then the opposite of this surface is the reflecting surface. Okay, so this is our silvered surface, and this is our reflecting surface. Okay, so light ray comes and get reflected by this surface. Okay, the direction of light ray is shown by the arrow. Okay, so this kind of a mirror is called convex mirror. Now, if we try to define spherical mirrors, then we can write which is a part of a sphere is called spherical mirror. So we can write a reflecting surface which is a part of a sphere. Okay, is called a spherical mirror. Now we need to know some terms related to spherical mirrors. Center of curvature. So center of curvature is the center of the sphere of which. So center of curvature is it is the center of the sphere of which we are cutting out the mirror. This is called center of curvature. Radius of curvature. So radius of curvature can be defined as it is the radius of the sphere of which we are cutting out the mirror. The center of this sphere is our center of curvature. Let us denote it by C. and the radius of this sphere is our radius of curvature. This is our capital R. Okay, I am showing it for a concave mirror. Now, if we extend, okay, now pole, it is the center of the spherical surface of the mirror. It is the center of the spherical surface of the mirror. That means this is the center. Okay, this is our center. This is called our pole. Okay, so this is our spherical surface of the mirror. APB. This is the spherical surface, and the geometrical center of it is called pole. Now, if we extend this line segment on both sides, we get a straight line, which is called principal axis. So, principal axis can be defined as the straight line joining the center of curvature and the pole of a spherical mirror. Okay, the straight line joining the center of curvature and the pole of a spherical mirror is called its principal axis. Now, another term, aperture. The part of the spherical mirror which receives incident light and is responsible for reflection. So in this case, this part is our aperture. So APP is our aperture. Now focus. Focus of a concave mirror. So let us assume this is our concave mirror. This is the reflect. This is the silvered surface, and this is our reflecting surface. Now this is our principal axis. Okay, this is our principal axis. Let us assume light rays are coming from infinite distance. So when light rays come from infinite distance, they become parallel to the principal axis. So incident rays or incoming rays which are parallel to the principal axis are striking the mirror, and after striking the mirror, they get reflected, and the reflected rays pass through a certain point on the principal axis. So here we can see the light rays parallel to the principal axis are coming towards the mirror, and after striking the mirror they are getting reflected, but They are passing through a common point on the principal axis. That common point on the principal axis is called a focus. Okay, so let us write the definition. When light rays incident parallel to the principal axis pass through a specific point on the principal axis after getting reflected by the concave mirror, then that specific point on the principal axis is called its focus. So this is our convex mirror APB. So similarly we can assume parallel rays, light rays which are parallel to the principal axis are coming towards the mirror and they strike the mirror, and after getting reflected they go in different directions. So this is the direction of the first ray, this is the direction of the second ray, third ray and fourth ray. So we can see in this case after reflection these rays, the reflected rays do not meet at any point, but in the previous case, in the case of concave mirror, the light rays are meeting at a certain point after getting reflected. After that they are going in different directions. Okay, but after the reflection from the mirror they meet at a certain point on the principal axis. Okay, but in this case the rays are not meeting anywhere. So now if we drag these rays backwards, they will meet at a certain point on the principal axis. This is our principal axis. Okay. So when we drag the reflected rays backwards, they meet at a certain point on the principal axis. Or we can say it in a different way. If we place our eye somewhere in front of the mirror, I have drawn it, our eye cannot see the bent path of the light. Okay. So these reflected rays appear to be diverging from a specific point inside the mirror. Okay. It seems that these rays are diverging from this point on the principal axis. Okay. So this point is called the focus. Now if we try to define it, we can write it like this: light rays incident parallel to the principal axis light rays incident parallel to the principal axis after getting reflected by the convex mirror do not meet at a specific point, but when the reflected rays are produced backwards, they meet at a specific point on the principal axis. This specific point on the principal axis is called its focus. Focal length. For a concave mirror, the distance between focus and the pole, this distance, the distance between the focus and the pole is called focal length. Similarly, for a convex lens, the distance between the focus and the pole is called focal length. The focal length is half of radius of curvature. Okay, focal length is half of radius of curvature.